Little background. My name's Christopher Stryker. I am a software engineer 3 / functional training lead at Hiller Measurements. What that really means is I like to think I know software stuff and tell people how to do things. So hopefully that doesn't come off too strongly. But I have been awake since this whole thing started, so it's running a little low. But anyway, the point of this is going to be quality at speed, driving software excellence. And without further ado, I'm going to start with our giants are female, if it will work for me. There we go. And I actually called out Fab. Fab is the lead architect for DQMH. She's a published author. More to the point, Fab is just inspiring. I met Fab at a user group for the first time years ago. And she just, if you've never worked with Fab, you're missing out because she embodies. I really struggled using Fab because I'm having trouble putting words to exactly what Fab is. But Fab is an enigma. And she is just a pillar in the LabVIEW community, and I really think she deserves more recognition. So this is my attempt to reach out to Fab and say, hey, Fab, you're awesome. So I'm not doing her justice, and I apologize for that. Disclaimers and opening remarks. This is being recorded. I say that not because I'm required to tell you that due to international privacy laws, although I think I might be. No, more importantly, I'm telling you this because this is all predicated on you using CI. If you're not using CI, you should really be using CI to the point that you should go somewhere else, watch something about CI in this hour, and then come back and watch the recording later because CI is that important. Also, I think in objects. I used to say I think in classes, but that is short-sighted. Just so as I go along, I'll talk about object-oriented stuff. Understand that's just the way my brain is wired and how I think. I hate presentations full of code. I went to one with Stephen Loftus-Mercer and John McBee this morning. It had a lot of code in it. I actually really enjoyed it. But generally, I hate presentations that are full of code because I just don't get it. It's way too, people go way too deep into the weeds, and I'm not smart enough to keep up. So I don't like making presentations full of code because I don't like preying on people like me. Also, I'm going to talk about ViAnalyzer tests. This is controversial, but I'm going to say not every one of your ViAnalyzer tests in your test suite will always pass. You're going to have tests that fail. That is okay in some cases. And finally, my unit tests are first-class citizens. By that, I mean I hold them to the same level of rigor that I hold all of my other BIs to in terms of code quality. So those are a few disclaimers and caveats. So I always make this slide for every presentation because I don't want people to be stuck in a presentation they don't know, they don't want to be in. So what is it? It's a discussion about Agile in a requirements-driven environment. It's a list of software measurements to facilitate rapid failure discovery and an overview of tools that I find useful. What it isn't is a case study, a blueprint, and just to reiterate, there's no code. So if you're looking for code, someone else has a presentation for you, I'm sure. So what is quality at speed? And I didn't do a nice thing with this font. I intended to make this a nice little quote. So quality at speed is a statement at Hiller, but it's not just a statement. It's really an ethos. We could spend the next 15 minutes talking about what is quality at speed, what is what we call Hiller Measurements flow control, and what the benefits are. That would be a marketing pitch. I don't do marketing. I used to think I wanted to do marketing, but it's exhausting, and I just don't have the energy for it. So I stole a quote from my VP, actually, and he said, "We do not usurp process, but we expedite it and reduce cycle time across the development cycle." And that is very true, but that didn't ring true for me. So what is it I want the software team to be doing to define quality at speed? So I slightly rewrote that. We intelligently and intentionally define our processes such that each stage has a specific purpose and objective. And by doing that, we're able to drive quality at a higher rate. So there's 4 pillars that I have identified behind that. We're going to look at water scrum fall, stay focused, shift risk left, and create and or use standard libraries. Water scrum fall. Okay, the first time I heard this, it was not used in a positive light. It was basically saying you're taking waterfall and some bastardized version of Scrum and saying, hey, this is your version of Agile, calling it Scrum, saying, hey, this is a good thing, trust us, we promise. And it was really diminutive. But I don't think that's true. So I'm going to reference what I consider the source of truth, the Agile Manifesto. So what it says, it doesn't say that the things on the right don't have value. In fact, it specifically says there is value in the items on the right. We value the items on the left more. I agree with that statement, with the caveat being, we do a lot of, I'll say, aerospace and defense work, but in certain regulated industry here. In these industries, whether the value we perceive on the right is really irrelevant because it is dictated by contract, regulation, and sometimes law. The right side must be there and have a certain weight. So given that, we need to make our development process fit into what is there. So what that means is, in some cases, let's look at a contract, for example, or processes and tools. Well, we need processes and tools to make sure we conform to the contract. And the contract has to be followed because if we make changes, that's a problem. So what we can do, though, is understand we have these rigid start and end points to the process for a waterfall process, if you will. We have the beginning where we declare all the requirements. We have the right, which is literally 100 check boxes at the end says, I have satisfied this requirement and this requirement and this requirement and this requirement. These are things we have to accept as facts. But we have this space in the middle, and the space in the middle is where we can really do Agile because there is value in being Agile. So one example, let's say we have various checkpoints, again, more formal, rigorous processes, but we're always incrementally increasing our software. We follow the concept of it should always, be a functional product, or it should always be functional, and you add functions, add increment as you go along. These are all important things. But the key is we can iterate and show things to the customer in either design reviews or informal settings. And a lot of the time we can get this feedback that Agile thrives on and dictates in manners that we can implement and make these changes without having to go rewrite the contract. And because all of these relationships we have with our customers are built on trust, the trust is there that we're going to actually follow through on what we say. Now, sometimes these customer meetings and iterations do produce hard requirements, and then there is a whole rigmarole we have to go through to change the contract, introduce another hard requirement, and add another checkbox to that list at the end. But overall, we're able to iterate it within a waterfall bookend. And I think that is something that is well described by water scrum fall and something that is often not considered. Another thing we talk about is staying focused. The analogy we use is, so first of all, don't build the kitchen sink when all you need is a water fountain. The analogy they use for the system level is you don't need a universal tester. Universal testers generally are a bad idea because they're going to be missing some feature that you need. They're going to have a million features you don't need. So you just paid a lot of money for something you still can't use without further modification. But from a software perspective, that also means we need to focus on only adding the features the customer has asked for And it means we need to make sure to keep things well scoped. So we need to stay focused. Shift risk left is another one of the pillars. And this is a really cliche thing. Everyone always says shift risk left, shift risk left. It's you know, you hear it everywhere. But there are examples of this that are actually actionable. So for example, it's not always obvious. I was working on a system one time where we were going to be using a database. And the way we needed to ship this system, we needed an installer and all this good stuff. So we decided we were going to use a MySQL database. So we're going along and doing the development work, and initial stages, I decided to do a license review, just review all the open source licenses. And I discovered that MySQL is not a permissive license. You cannot repackage it with your product for commercial purposes. Okay. There are commercial provisions, so we went and looked at that, and the commercial provisions just didn't really satisfy our needs. So I went looking for a different option, and I found one. Postgre was perfect for the bill. But because we did change the plan of record, which had been to use MySQL, I went back to the customer and said, hey, customer, we changed this. Why don't we just talk about all the licenses we're using just for the sake of making sure we're all on the same page? And it's really good I'd done this, because I selected an open source execution framework. Excuse me, back up. I'd suggest a free execution framework that was not open source. And it had a proprietary license. Now, this proprietary license said you can use it all you want for free purposes. You can charge for it. That's not a problem. It fit my situation just great. But it did have some provisions in it about about protection of the original company's IP. So they basically said, you have to protect our IP and you can't reverse engineer it and you have to do good things. Well, my end customer didn't want the obligation of protecting that IP. So because we had this conversation and iterated through the process, we discovered that it was going to be an issue. Now, could we have used this framework as is with the existing license agreement and still met all of the requirements? Yes, probably. Would the customer have been happy? No, they would not have. We would have made the sale, but the customer would not have been happy, and I would not have been personally satisfied with that. But because we caught it early enough in the process, we could discuss things, we could make changes, we could iterate without having to go rewrite a full contract. And this is an example of how Agile can fit into the waterfall process while shifting risk left. And then finally, create and or use standard libraries. One of the key tenets of the killer measurements flow control is reusable, is to reuse the same things over and over again. We have a standard catalog of instruments that we use. Well, we can write drivers for all of those instruments. And if we write drivers for all of those instruments, we kind of have a shopping list we can go to and say, pull this one, this one, this one. Okay, we've used all these things together before it works. This isn't shocking, but when you do it on a large scale, it starts working well. So now that I've bored you all with the concepts behind how I feel Agile fits into a waterfall world, let's talk about what you came here for. Let's talk about catching defects. We're going to talk about a few different types of defects in this presentation. So I'm going to call out 4. We have variance from specification. As we discussed, we have rigorous specifications and they must all be met. So if we do not meet one of those specifications, it is a defect. Variance from what makes sense. I consider it a defect if it doesn't work the way it seems like it should. Metrics falling outside an established range. We're going to talk about various measurements as we go along. And to be clear, a measurement is something you can measure, and a metric is a result of taking that measurement. So a metric falling outside an established range means a measurement is not giving you the result you expect. And finally, anything that requires refactoring to continue additional iteration, I am going to call out as a defect. That means we didn't do it right the first time. So the first is sometimes in conflict with the second. Sometimes what the specification doesn't make sense. I don't have a good answer for that one, I'm sorry. It always ends in a hard discussion. The fourth, refactoring is often considered part of iteration. I recently used to think that the goal of iteration was refactoring. It is in fact not. The goal is to add functionality, not throw away good code. So, refactoring is a defect, let's be clear. So why do we care about defects? Well, it's kind of obvious, but to fit into what I was just discussing, it shifts risk left. You can measure progress by detecting problem areas, and you can find requirements errors or incompatibilities. Pardon me. So we have defined a defect. We've talked about why we want to find them. So how are we going to do it? I propose 6 primary mechanisms: reviewing design concepts and reviewing proposed implementations. These are both really good at catching things in the first stage with regards to the errors in the first 2 that we discussed. So variance from specification, variance from what makes sense are both going to be caught often in the review stage. Now the last two, the system tests and deployment tests, I'm going to argue many times the developers will not have visibility to, especially the deployment tests. Deployment, I'm saying, after the product has been used for 6 months, how's it working? Your developers often aren't going to see that. The system tests, arguably, you might see more, but by the time it gets to system tests, you have a bigger problem. So I'm going to focus specifically on unit tests and code reviews. And by code review, I often mean an automated process, not a low-level design review. So let's talk about types of measurements. I just alluded to it, but if it requires manual analysis, I will not use it as a driving metric. For example, number of key classes relative to number of support classes. It's a great thing to look at. It's a great metric. It will tell you, how well structured is my object-oriented hierarchy. Let me finish this thought and I'll come back to you, James. So the reason I won't use a non-automated metric, there's 2 reasons. First of all, the chances of me and someone else looking at it and evaluating it the same way are nearly impossible. That's going to mean one of 2 things. Either A, I'm the one that always has to do the analysis for every single project for it to be consistent, or B, I can't trust it because I don't know who did it. Neither one of those things are good, and both of them make the metric basically useless to me. So in terms of using it to evaluate the state of the project and using it for decision making, I will not use a metric that cannot be generated automatically or in an automated manner. That doesn't mean it can't be manually interpreted. That's fine. Let's say, well, we'll see as we go along. But the fact that I have to look at it and say, what does this mean? That's fine, because we can have discussions about what it means, but we can't. We need to be working from the same point. So what I'm about to talk about is a list of measurements that I'm either tracking now or will be in the near future. I'm going to elaborate on some of them. Others I'm going to leave for future discussion. But first, I'm going to circle back to Mr. McNally's comment. I'm afraid I have to disagree strongly that refactoring is a defect. It may require a definition of have to refactor. Often I find refactoring is part of a natural evolution of the code as you learn more. I'm not saying refactoring is bad. Refactoring is a very good thing. I'm also going to say if you're not writing bugs, you're not writing code. So if the fact that you're writing, the fact you're making defects is not a bad thing. Does that kind of reconcile with what you were thinking? You're welcome to share your video if you'd like to chat. I'm all for that. Can anybody hear me?
Yeah. So I think James is coming in now. So.
Okay, sorry.
Yeah, sorry. I've got my camera off because I've just woken up with a nighttime feed of the baby. So.
That's fine.
So, yeah, I'm trying to reconcile that in my head. It's maybe a strength of emotion associated with the word defect. There is refactoring, to me, there's two sides to refactoring, right? There is, oh, this design doesn't work. But also I find refactoring is sometimes a natural first step of we have something new to put here. Let's make the code ready for putting that in. And so in that latter definition, I find it's not really a rework thing. But it's somewhat semantic at that point.
Yeah, and I really agree with you that it is a good thing and something that's unavoidable. What I really think I want to emphasize is that you need to know that there are going to be defects no matter what you do, and to look closely at the ways you find them. Because if you're making changes, that means what you did wasn't right to begin with. Now, whether you had any way of knowing it wasn't right or not, or it should have been right, is a different story.
Yeah, and that's an important factor.
Yeah.
Again, right is a very loaded term in that.
It is.
It was
it
correct
is.
at the time of writing, but it could
Exactly.
not be right now. Yeah, I see what you're getting to.
Yeah, so this goes back to somewhat a conversation I had when I was interviewing Hiller. They said something about, I don't remember what the setup was, but I said, I just really like making sure things are done the right way. And I could see their hackles raise when I said it. I think I almost lost my job right there when one guy heard me. I said, no, wait a second. And they said, well, what's the right way? I said, that is completely dependent upon the situation and the policies at the time. And I think it's really important to recognize right is not distinguishable until you're done sometimes.
I like that.
So
thank you.
Okay, no problem. Sorry to put you on the spot.
No, not at all.
Okay, so with that, I'm going to jump back in and let's talk about these specific types of measurements. So I think I lost it. Hang on a second. There we go. Okay, general tests. ViAnalyzer tests. I love ViAnalyzer. We're going to talk more about ViAnalyzer towards the end. So just table that for now and know that I love ViAnalyzer tests. With one key differentiation I'm going to make right now, when I run my CI, I run ViAnalyzer twice. Once for general niceness, to pick out things that I think are generally good to keep track of, but if they're wrong, I don't break the build. If you have too many wire bins, I want to know. I want you to fix it at some point. But I don't care enough to stop you from getting your code in if you're in a hurry. It's a necessary evil. However, if you're putting broken VIs in, or VIs with breakpoints, or VIs without separated source code, those I care about, and those I don't want in the code base, period. Not cool. So I will fail the build or fail the submit on the second case, but the first case I'll let through and use as a heuristic rather than a gating feature. So that's my rant on ViAnalyzer for the moment. VI size. At one point, I'm referencing VI size in number of nodes typically. At one point, NI had published that one line of code is equivalent to one node in LabVIEW. To meet some requirement, I think is why they said they needed some official guidance and all this mess. That number's junk. But any number regarding strictly lines of code, regardless of your language, is a junk number. But by looking at the size in a relative sense, you can get useful information. A lot of small VIs are better than one ginormous VI. So this is a number that I'm still trying to find a correct size, a correct number for. I'm looking at the number of nodes in the VI. Code complexity, I think, is also a very important thing to look at. But again, I don't have a mechanism nailed down yet for code complexity, frankly. The code complexity built into the LabVIEW editor to evaluate code complexity on a VI level is very useful, but that's evaluating your VI, which is not helping me if I care about the whole system. And the whole system is really where the complexity is I care about, because that's what's going to bite us. The VIs themselves are unlikely to cause a huge problem. And then finally, the usage of functional global variables. I don't like functional globals. I'm going to let that sit there for a second. Functional globals are essentially often used as references. If you just saw Darren's presentation, I'm not going to go too far into the weeds because Darren said it probably better than I ever could. Globals are bad, except when done correctly. But let's be clear, a functional global is no better than a global, so don't just wrap it as a functional and tell me it's okay. It requires thought. Now, how do you define a functional global? That becomes the problem. I am going to define a functional global as any VI with an unwired shift register. That's very easy to check for. And essentially what that means is I'm preserving state from run to run, or I have an undetermined state. Well, no, the state's always determined. But so it's preserving state from run to run. That's how I'm defining a functional global. Yes, there are cases where that could be wrong, but by convention, I don't want unwired shift registers anyway, unless it is a functional global. Therefore, that is the metric I'm going to use.
Chris, do you put that in your first or your second group of tests?
Everything I am describing, with the exception of the breakpoints, broken VIs, and separated compiled code, is in my first test, the general test that gives me the overall status. I'm railing against these things, but I'm not going to keep you from submitting code necessarily. There are points of evaluation.
Okay, thanks.
So let's see here, where are we at? Class size. The number of public methods in a class, the total number of methods, and the distribution of methods between classes. So I really like the number of public methods because it does well to evaluate the single responsibility principle, in my opinion, because the more things it's trying to do, the more methods it's exposing, chances are the more things it's doing. Total number of methods is also a very interesting metric for me to look at, because if you have a bunch of private methods in a class, that can also indicate maybe it's a very busy class behind the scenes and needs to be further broken down. And finally, distribution methods between classes. My concern is if you have one class that has 100 methods in it and 3 classes with 10 methods apiece, chances are something's not right. But if you had 10 classes with 100 methods apiece, that might be valid. But seeing that disparity will really introduce some obvious things, hopefully, or at least show you places to look. Class inheritance. So nesting level. The nesting level of your hierarchy is going to be very dependent upon the framework you use. So if you're using many different frameworks in your development flow, this is not a number you can look at between projects. However, if you are using a consistent framework between projects, which that is what we try to do, it is a good revealer of your level of specialization. If you're using specialization correctly, you will have a few child classes below your framework level in most cases. If you're not doing your specialization correctly, you can have override after override after override after override, where each method overrides something in the parent and does it differently rather than adding some special sauce, which is what specialization should do. And then if you don't have any hierarchy, that means you're not using OOP effectively. So number of interfaces. Give me a second. I need to go find my flame-proof suit. I think it's at the cleaner. That sucks. Okay, here we go. We're going to start using interfaces in the near future at Hiller Measurements. I'm going to track the number of interfaces implemented by a given class. That is because I think interfaces are a code smell. I love interfaces. I'm so glad we have them. They are the only intelligent way to implement a hardware and measurement abstraction layer. However, the whole reason they make such a great hardware and measurement abstraction layer is because you can violate the single responsibility principle. You can make one class do 30 different things because you can inherit 30 different interfaces. Now, I really, really, really hope I'm wrong about this. I'm not using it to drive any decisions right now, but I am going to watch very closely how the number of interfaces in a given class correlates to the number of defects that end up being found in that class. Someone tell me I'm wrong.
I want to see another presentation on this in a year's time with your findings on that. James says he thinks you're right.
Yes, I really hope I'm wrong because I love interfaces so much. They're going to make so many things easier. But I just want to make sure I'm not painting myself into a corner with them. So now that I've shot myself in the foot on that one, although to be fair, I did ask this in a question earlier.
I come with my comment.
Yeah, go for it.
So in ideal world, we follow single responsibility principle. In real world, no, because and there are practical reasons. One reason is that LabVIEW actually doesn't work very well if number of classes too large. Second reason, class represent a physical thing. For example, if we represent PXI as a class, we need some kind of compositely aggregated or aggregated classes represented in every unit inside PXI. We need class representing not every channel, but type of channel, say so. And as a result, we have very, very complicated combination. But many units, we cannot split because they are multifunctional at physical level. So I gave a presentation about interfaces. For example, we have hierarchy of classes where we have some units which are able to use synchronization, units which are simple and cheap and are not able. And in this case, interfaces actually enforce single responsibility because interface can be applied to say this interface is single responsibility, while classes could be larger units. This is my comment.
So I think what you said, so first of all, are you saying your class inherits from multiple interfaces?
Yep.
Okay. So I think the key is single responsibility principle is a great goal. It's never going to happen.
Exactly.
I think interfaces push you further from it.
Yes.
However, there's also a benefit in moving further from it, which I think is what you just identified.
Yes.
So my thought is at some point in the middle, there's going to be this, this class implemented 12 interfaces and I found 30 bugs in it. But this class interface implemented 2 interfaces and I found 1 bug. So somewhere in here, there's going to be a sweet spot of magic numbers that all line up. And I think it's not going to be the class with the highest. I think you can't have too many interfaces to offset the benefit you gain from implementing functionality.
You know, I think we are at the very beginning of using interfaces. And because of it, we don't have routines. Many routines which we use with interfaces, we just developing them routines, each of us. Maybe after a year or 2, we meet here, or maybe physically. So, and we will really laugh together about my idea, what was, how they were, in which underdeveloped state they were today.
Right. And
So my comments is not actually true. It is just thinking how to move in right direction.
Yeah, when I was at NI, for a little bit. We had this motto. It was trust but verify. I trust interfaces are going to be a good thing, but I'm not going to take it without measurement. I'm going to verify that I'm actually getting the benefit I think I'm getting. So I'm so excited for interfaces. I don't want to throw water on them. I love them to death, but I'm just, something's tingling up here. So
Yes.
Thank you for the comment.
I don't know if James wants to jump in and talk through this, but he also was saying something similar about different levels of interface, large responsibility interfaces or smaller interfaces that perform basic operations on the class.
Yeah, and it'd be nice if I could come up with some mechanism for wading through and saying, well, this one class implemented 3 interfaces, but there were a total of 30 methods between the 3 interfaces that it inherited, and this class implemented 10 interfaces, but there were 10 methods total from the different interfaces. So it'd be nice if we could slice and dice on that granular of a level. I'm not there yet. Maybe by next year I'll have something that we could maybe look at, but I won't have any data I trust yet. My goal is to outline and have people call me out right now on my metrics and tell me I think those are junk. And then I can actually go through and start actually categorizing all of this stuff. And then we can meet back in a year and see where I'm at.
So far, nobody seems to be disagreeing with you.
Yeah, it's kind of disappointed. Okay. Method inheritance, number of overrides. A large number of overrides, I kind of alluded to this earlier, means you aren't doing specialization correctly. If you have to override every single method, it probably should be maybe a sibling instead of a child. And even then, looked at a different slide. Number of overrides. If you are overriding a lot of things, that means that you're not using the specialization correctly. If your VI invokes call parent method and then uses the result of call parent method to then further specialize that action, I think that's actually a little more allowable. So I'd like to build a caveat into my test such that it doesn't count as a new method, as it doesn't ding it if it calls parent method. So I think that is a valid use case. Number of inherited methods. The majority of the methods a class has should be inherited. It should either get the functionality from the parent or do a slight override. It shouldn't introduce a billion new methods in it, which also segues into the number of methods added. I would argue the number of methods added would ideally be inversely proportional to the nesting level that we talked about earlier. Your higher level classes are going to have a lot of functionality. But by the time you get down to that third nesting level, you should only be tweaking 1 or 2 little things as you go along. And let's see, I'm getting close to time. Okay. Class internals. Cohesion. We all talk about cohesion. I'm going to define cohesion thusly. I'm going to measure the number of calls to classmates relative to external calls. I'm also going to ignore anything in ViLib. But that said, we, Hiller Matrons, don't install things to ViLib. So you might want to reconsider that exclusion. Also, if you install a bunch of stuff to ViLib or user-lib or instrument-lib, you might reconsider your life choices, but that's another debate I'm not going to get into. I think I stepped on some toes with that earlier. So I hate user-lib and ViLib, but we won't go there right now. But with regards to cohesion, the more calls it makes to itself and its classmates, the more cohesive it is. I think that's fairly obvious. Number of terminals on a con pane. This equates to number of parameters per method in most text-based languages. I don't think any of us are going to argue that large con panes are a good thing. Percentage of function-oriented code. Now, again, I have said I think in objects. I consider function-oriented code something that is not in a class. I also consider clusters to be function-oriented code. I think clusters are inherently a code smell. If it is a cluster and is used a whole lot, maybe you should think about making it a class. This is not a hard and fast rule. This is almost along the interfaces concept of something I'm looking at that I think is, I'm really going to see something there that I don't expect. Well, I expected, so something I don't like. But I consider clusters to be not great either.
Andre would like to know how you feel about singletons.
I'm sorry?
Sorry, Andre would like to know how you feel about singletons.
As in singleton data structures or singleton DQMH modules? Sorry, I need some context.
He's gonna jump in.
Okay, I have to enter the room again.
Yeah,
so singleton, okay, maybe they're not so common in by value programming, but very common by reference programming. From general object-oriented programming. Singleton, this is a class which can be instantiated only once.
Oh, yeah.
So
yeah,
many people use them. What do you think about them?
I've not gone too far into that into the pool because I'm not a huge fan of references in general. I try to avoid them when possible. But without a lot of thought exercise, I don't see an immediate problem with them. I see them as a very useful thing for some applications, so I would certainly never say don't use them. Because I do see many cases where they are required. You're dealing with a piece of hardware, you need a class to represent it. You only ever have one piece of that hardware in the system. Yeah.
Okay, I probably my question was wrong, because if you use by value classes, it's a little bit different. Say so. But probably we have to start holy war in some private room about by reference and by value.
Yeah, absolutely.
Yeah, thank you very much.
No problem. Let's see here, and where was I at? Percentage of functional-oriented code and number of bugs found per class. I think this one's pretty obvious. It's not. It's used as an. I'm going to use this in conjunction with the other metrics we've looked at to determine, which of the things. Why is this particular class having so many bugs? Well, let's look at everything else that's wrong with it, or all the other characteristics of it, and see if we can find a trend. The ones with the most bugs also have these characteristics elevated in the same places. So let's see here. Let's move on a little bit. Okay, we can get there. Class externals, coupling of classes. I'm going to define this as the number of classes collaborated with and relative number of calls each. So by that I mean if a given class calls another class significantly more often than all the others, those two classes are probably coupled. And the number of reuse times, this is actually a really good thing. The number of times reused between projects, the more times we reuse it. Obviously, it's a better class, so maybe we should look at that class and see what it's doing right. So now we're going to talk about measuring our metrics. The first thing I'm going to measure is the number of files thrown away. I want files to be thrown away. If I'm not throwing files away, I'm not finding bugs. This flies directly in the face or ties very closely with refactoring being a bug or a defect and therefore a source of bugs. This is that double-edged sword. You should be throwing files away. You should be making mistakes. Therefore, you should be throwing files away. If you're not making mistakes, you're not writing code or you're not looking hard enough. This is also similar to the ratio of bugs reported to the number of files. Again, there should be a measurement in here somewhere saying this ratio is what I expect. Okay. Also, the delta of specific general ViAnalyzer failures. So by this, I mean I ran this VI. I ran the analyzer on this VI and it found 3 bad wire bins and 2 incorrect display styles for strings. Sure. The next time I analyze that specific VI, I want to see those same failures or maybe less. I don't want to be adding specific failures to any given VI. That's all really simple to measure, right? Well, It is now. So what I've done is build a GitLab ViAnalyzer task that generates what they call a code climate report for GitLab. And what this does is show me exactly what things have been fixed or what things have been introduced in each specific VI and tracks my changes over time. So in this case, you can see I fixed 428 distinct ViAnalyzer tests, made 7 worse, and only and didn't change an unknown number that I can find in a different screen. I think this is pretty darn nifty. I'm kind of proud of it, and it has changed my development workflow. The code is out there on our GitLab site for Hiller Measurements. I like to think it's well documented. I can read it. So, but seriously, if you're interested, go check it out, pull it down. I'll give a blog post here in a minute that also has some resources for that, and you can see how it's used. Additional tools, I like ViAnalyzer a lot, in case you haven't gotten that already. I use various GitLab CI pipeline visualization tools. Use a unit test framework that outputs JUnit. I love Karaya. You're going to have to pry it out of my cold, dead hands. But if you want to use something else that outputs JUnit, that's your prerogative. And finally, I have a tool still in development that's going to enable a lot of this as well. Critical ViAnalyzer tests, we already talked about this, but breakpoints, broken VIs, and separate compiled code should be on. So those things I will fail and not let it in the code base. General tests, I'm not going to give you a list, but I am going to tell you where I like looking. I think these are some of the better categories. And then there's also the ViAnalyzer forum at ni.com. It's a great resource. And with that, I am going to open it up for questions. I think I am right at time. Cool. So yeah, I think we've got about 10 minutes to play with before the next presentation comes in, and then if we need to, we can move to the breakout room.